When we think of a mass extinction, an event where huge numbers of species are wiped from the face of the Earth forever, the first one that comes to mind is most likely the End Cretaceous or KPG extinction that occurred 66 million years ago. This is by far the most famous example of a mass extinction and has been featured before on this channel. It is the infamous disaster that wiped out the non-avian dinosaurs. Many scientists have noted that we're currently in the midst of a mass extinction today. Human advancement and interference has resulted in the dramatic decline of many amazing animal species, which could see thousands of species become lost to time if action is not taken soon. Although these extinctions are the most prevalent in society today, they are by no means the most impactful or deadly that our world has ever experienced, discluding the one we're potentially living through. That's not to say they're not important by any means, but one mass extinction stands above the others as the greatest threat life on Earth has ever faced. This grim accolade goes to the aptly named Great Dying, a mass extinction event that took place around 252 million years ago. Formerly known as the Permian Triassic extinction event, this utter horror of biological loss caused 90% of all known species to become extinct. So, what happened? In today's video, we will be exploring what the world was like before, during, and after the Great Dying. We will be meeting key species that were lost and that lived through the extinction event, and will explore the causes and effects the disaster had on the planet. Sit back and relax as we take you back to the end of the Permian to discover a time when volcanoes wiped out 90% of all life on Earth. Before the Permian Triassic extinction event, the world was abundant in animals, both familiar and unfamiliar. One global continent composed of all the world's major landmasses, Pangaea, supported all terrestrial animals on Earth, while one huge ocean, the Panthalassic, supported the planet's marine life. This was the late Permian period, the final act of the Paleozoic era before the age of reptiles. The world had long since emerged from the Carboniferous period, and as a result, huge swamp forests had been replaced by vast swaths of open, arid land. Scrubland, desert, and woodlands were common across the world, the latter being made up of ginkgos, cycads, and conifers that would become commonplace across the age of the dinosaurs. In the seas, sponge reefs were common, which supported a wide range of vertebrates and invertebrates. Amidst the rocky reefs, brachiopods filtered food through the water current, while ammonites drifted above them in huge numbers. Fish, both of the lobe-finned and bony variety, were common in the oceans, as well as sharks and their relatives who had firmly established themselves as some of the top predators of the oceans. Inland, rivers and lakes were occupied by large aquatic amphibian-like vertebrates, some of which grew particularly massive and lived like modern crocodiles. On land, life had exploded into an array of new forms. Two major groups of terrestrial vertebrates diverged and diversified during the Permian, and had spread across the planet by the end of the period. They were the synapsids and the sauropsids. The synapsids, identified by their skulls with one temporal opening, would eventually give rise to the mammals, but were not true mammals themselves. The sauropsids, on the other hand, identified by their skulls with two temporal openings, would eventually give rise to the reptiles, and in turn, the birds. By the end of the Permian, synapsids were more common and diverse than the sauropsids, and included a wide range of groups, families, and species. Lystrosaurus, a pig-sized browser with short downward-facing tusks, was amongst the most common animals of the late Permian and represents one of the most amazing evolutionary success stories in all of natural history. Remember that name. You'll be hearing from Lystrosaurus again later in this video. Not all synapsids were as humble in size and shape as Lystrosaurus, however. You may be familiar with the Gorgonopsids, a group of large predatory synapsids with huge saber teeth. The largest of these, Inostransevia, perished in the Great Dying and would have been one of the largest and most powerful predators of its time. Another widespread group of synapsids were the Therocephalians, a group of primarily carnivorous dog-like animals that hunted other synapsids and sauropsids. Throughout most of the Permian, these animals would have preyed upon vertebrates such as Dinocephalians, a group of large, often herbivorous synapsids that disappeared just before the Great Dying. Some Dinocephalians, however, such as Antiosaurus, were the largest terrestrial carnivores of the entire Permian period. Some of the most awe-inspiring sauropsids that lived just before the Great Dying are the Periosaurs, a group of massive, bulky para-reptiles that included genera such as Scutosaurus. These huge, almost dinosaur-like animals would have been browsers that interacted with and lived alongside our very, very distant synapsid ancestors. Other sauropsids were much more agile, so agile in fact that in some instances, such as Coelurosaurus, gliding mechanisms had evolved. These reptiles, known from Madagascar, swooped from tree to tree using flexible projections from their ribs. This is just a brief snapshot of the life that existed in the Permian world before the Great Dying. The world was abundant in animal and plant life, and had it not been for the forthcoming extinction event, it may have been the synapsids that rose to prominence during the following millennia, and not the dinosaurs. However, we know that this is definitely not the case. Gorgonopsids and Therocephalians did not rule the planet over the course of the Mesozoic. But why exactly? Enter the worst mass extinction in the history of planet Earth. It's important to note that it's hard for scientists to paint a truly accurate picture of what caused this mass extinction. We're talking about an event that took place over 250 million years ago, and as such, there's not a wealth of evidence left behind that points to the specific processes and timelines. Despite this, however, theories have been put forward. The most commonly accepted of these theories is that volcanic activity caused the Great Dying when the Siberian traps erupted as they were created. The Siberian traps make up a volcanic area in what is today northern Russia, created by basalt eruptions in the region at the end of the Permian. As they were hauled up from the ground, cataclysmic eruptions took place, causing one of the quickest rises in levels of carbon dioxide the world has ever experienced. Along with the massive injection of harmful CO2 into the atmosphere, the Siberian traps also released halogens that damaged the ozone layer. Dust clouds would have blocked out sunlight for extended periods of time, disrupting ecosystems on land and in the oceans. The eruptions have also been theorized to have produced storms of acid rain, killing land plants and invertebrates that large animals depended upon for food. Steadily, the world choked. As winds carried harmful greenhouse gases along with pyroclastic ash around the world, many organisms found themselves unable to cope with the changes in atmospheric conditions and the lack of food in their ecosystems. As the plants died, the invertebrates and herbivorous vertebrates that depended on them disappeared. At first, this would have been a bountiful feast for scavengers and opportunistic carnivores. But with no living prey animals to reproduce, the carnivores would soon find themselves extinct too. In the oceans, As sunlight blocked the reproduction of plankton, many species of marine invertebrates and fish began to die out. With nothing to prey upon, the larger marine vertebrates soon became extinct too. Carbon dioxide would have dissolved into the seas, limiting the oxygen available to the organisms that weren't immediately wiped out by the conditions in their ecosystems. It was a terrible time to be living on planet Earth, and the natural world experienced catastrophic consequences as a result. The sheer amount of death and decay is difficult to put into words, but this would have been the greatest loss of life our planet would ever experience. Over a period of a few 100,000 years, entire lineages were wiped out, species disappeared, and roles in ecosystems were left vacant. Several lineages of animals would disappear from the Earth entirely during the Great Dying. Some, such as the many groups of arthropods that became extinct, had been widespread throughout almost the entirety of the Paleozoic era and were gone in the relative blink of an eye in geological terms. Eurypterids, carnivorous sea scorpions that were common in the shallow seas of the Paleozoic, became extinct during this period, as did the famous trilobites. The latter, whose fossils can be found immaculately preserved all over the world, were amongst the most common marine invertebrates on Earth in the Paleozoic, but could not cope with the changes in their ecosystems. Groups of animals that survived the Great Dying suffered extremely heavy losses. In the seas, over 90% of brachiopods, ammonites, gastropods, and crinoids went extinct, but were able to recover and prosper throughout the Mesozoic. On the land, reptiles suffered massive losses, with anapsids, a primitive group of reptile relatives that thrived in the Permian, almost dying out entirely. In South Africa's Karoo Basin alone, a fossil hotspot for late Permian vertebrates, between 54 and 69% of animals became extinct as a result of the mass extinction event. Therocephalians managed to barely make it through to the Triassic period, but the larger gorgonopsids vanished in the disaster. With them went the large tortoise-like periosaurs, too big to sustain themselves on the meager plant matter that was available once the world became a death trap. The animals that typically survive mass extinctions are the generalists, creatures that are able to adapt to different situations by exploiting a wide range of habitats and food sources. Examples of generalists in the modern day include animals such as rats, corvids, raccoons, pigs, and coyotes. Animals that are specialized to suit a niche role in an ecosystem, such as large browsers or pursuit predators, soon become extinct if there's nothing to feed upon when conditions change for the worse. Therefore, just as it was at the end of the Cretaceous mass extinction, the animals that inherited the Mesozoic were small, adaptable, and robust. They were able to make a living on the little plant or animal food matter that was available to them, and could adapt to the dangerous conditions of the atmosphere by living perhaps in burrows or caves. Those who managed to make it through would find themselves in the Triassic period, the dawning of the age of dinosaurs. By evolving to suit the new ecological niches available to them in this arid world, the synapsids and sauropsids that survived took on new forms, radiating into all manner of shapes and sizes. Perhaps the greatest success story of the Great Dying comes in the form of little Lystrosaurus, the pig-sized herbivore we mentioned earlier in the video. This small, tusked generalist was by far the most common animal alive in the wake of the mass extinction. Capable of making it through the harsh conditions by living and feeding in sheltered areas, Lystrosaurus soon became abundant and spread out across this new world. In some locations, Lystrosaurus species made up as much as 90% of all terrestrial vertebrate fauna. Its fast growth rate and adaptable nature made it the perfect fit to inherit this new world. Lystrosaurus was not alone at the dawn of the Mesozoic, however. Carnivores had made it through to the other side too. Therocephalians are well known from the Karoo region following the Great Dying. They too may have lived in burrows to escape the harsh conditions of the surface world, emerging when the world ceased to choke on ash and gas. Ictiodosacoides and Tetracynodon are great examples of early Triassic therocephalians. With sharp teeth and slender snouts, they would have snapped up small vertebrates from within the ground. For the most part, however, the Triassic would not belong to the synapsids. Across the period's early stages, some of Lystrosaurus's relatives were able to evolve into gigantic hippopotamus-like browsers and could still be found in many ecosystems across the Triassic world. However, the sauropsids had survived too, and would go on to become the most successful animals on the planet by the end of the Triassic in the form of the dinosaurs. Even before dinosaurs came along, however, the sauropsids were thriving. Archosaurs, relatives of dinosaurs and crocodilians, were quick to recover from the extinction event and became top predators in some ecosystems. Some, such as the gigantic Erythrosuchus, a 5-meter-long carnivore with huge jaws, were the first apex predators to arise from the extinction event and would have made short work of our synapsid ancestors. As the climate became more humid and forests made recoveries, reptiles were able to diversify even further, taking on all kinds of forms. Some resembled crocodiles and lizards, while others became large herbivores dwelling in wetlands and swamps. Throughout the Paleozoic, much of the world was wet, covered in great swaths of riverine systems and swampland. Although the world generally became much more arid in the Permian, giant amphibians were able to cling on to their fearsome reputations and made it through to the Triassic. Animals such as Mastodonsaurus, gigantic amphibian apex predators, would soon evolve to fill the role of aquatic ambushers and remained successful throughout much of the Mesozoic. Although they would never again enjoy the widespread success they achieved in the Paleozoic, they were a constant concern for any small animal taking an opportunistic drink at the water's edge. In the seas, life was beginning to explode into color and shape once more. Although in the millennia immediately following the Great Dying, the seas were sparsely populated by conodonts and brachiopods, this would soon change. Species here too were evolving to fill vacant ecological niches left behind by those who had become extinct, and a wide range of vertebrates and invertebrates soon took to the oceans. Abundant communities of sessile animals, filter feeders that attach themselves to the sea floor, soon developed and were able to sustain much larger animals in turn. Soon, mollusks and echinoderms would make a comeback, and along with them would come more complex animals such as crustaceans. Once the pieces were in place for them to evolve, marine vertebrates made a steady comeback too. In the first few million years following the mass extinction, ichthyosauriforms appear in Earth's waters. These basal ancestors of the fish-like ichthyosaurs were some of the largest animals in the oceans after the Great Dying, using their powerful flippers and long jaws to snap up abundant fish and marine invertebrates from the waves. The earliest known member of the group is Utatsusaurus hattai, a 3-meter-long dolphin-like piscivore from what is now Japan. For an ichthyosauriform, this was surprisingly small. Later ichthyosauriforms, such as the mighty Symbospondylus, would grow to sizes in excess of 10 meters as they hunted large fish and marine reptiles in the shallow coastal seas. From this point onwards, throughout the Mesozoic, marine reptiles would rule the seas. The massive void of large marine animals meant that once the oceans recovered, marine reptiles could evolve to take on all kinds of forms, and some became very, very peculiar as a result. Some, such as Hupasuchus for example, were bizarre filter feeders. With the body of a crocodile, the snout of an ichthyosaur, the limbs of a turtle, and the mouth of a baleen whale, this strange product of Triassic evolution scooped fish and small invertebrates from the waves around the shallow seas of Triassic China. On the coastlines, animals such as the strange, tanystrophiid reptiles began to evolve. These animals, equally resembling snakes and sauropod dinosaurs, used their immensely long necks to fish for marine vertebrates by the water's edge. Perhaps the strangest of all was Adipodentatus, a diving herbivore once believed to have possessed a seemingly ridiculous zipper-like mouth running vertically along its upper jaw. The reality wasn't much more familiar. This reptile used a broad, duck-like snout to shuffle up vegetation from ancient seabeds. The Great Dying, as tragic and terrible as it was, shows just how well life can recover from even the worst natural disasters. Never before or since has life on Earth sustained such substantial losses from an extinction event. We'd like to say that this would never happen again on such a scale, but we're currently living in a time of ecological crisis. All over the world, human activity has depleted environments, decimated organism populations, and is continuing to put countless species at risk. Never before has a single species been responsible for such damage to so many other species in the natural world. While the responsibility mainly falls on governments and corporations to regulate and limit the damage done to our world in the modern day, we could soon be facing another mass extinction potentially on par with the Great Dying if action is not taken. Let us hope that we as a species can see sense before it is far too late. Even human activity, however, will not ultimately stop the flow of life on Earth. Animals have been here long before us, and they will be here long after us. Today, it is a matter of saving as many species as we can from extinction, so that life will flourish for millennia to come.